Thank you, everyone. So thank you for being here. Today we have a lot to show, so I'm going to go a little bit fast in the beginning. Why are we here? We're here because we all know that companies are drowning in data, accumulating more and more data. That's the good news. The bad news is we don't have enough power to process all of this data, and developers are getting more involved into solving data problems. So in this talk, I'm going to show how we can make the collaboration between data scientists and developer much better, and maybe beyond developer, the line of business users. So how do we blur the line between developers and data scientists? So what I would like to do for this talk is tell you a story that we all know too well. Let's start with Ben. Meet Ben, the developer. He holds a master's degree in computer science, 10 years experience, typical web developer, full stack. His favorite quote is the best line of code is the one I didn't have to write. So Ben, his focus is build it. How can we make it cheaper to run? Meet Natasha. She's the data scientist. She holds a PhD in data science. She has 5 years experience. She's experienced in Python, R, machine learning, but software engineering is not really her thing. Her quote, "In God we trust, all others bring data." So they all work at this company, Acme, Monday morning, surprise meeting with the VP. And that's not to get a promotion, as you can imagine. We have an urgent need for our marketing department to build an application that can provide real-time sentiment analysis on Twitter data. And by the way, you only have 6 weeks to build it. You can use whatever you want, but I really want you to look at Apache Spark. And also, I want you to build a user-friendly dashboard. I don't want you to give me a notebook with a lot of cells, with a lot of algorithm. I want something a little bit more user-friendly. So Natasha starts. What is Apache Spark? Oh, Natasha. Great question, but I think the best way is to send you to Spark Summit. She's here, actually, Natasha. No, it's just the fictional characters. But moving on. How do we consume Spark? 2 ways. Batch, with Spark Submit, and interactive notebook. But you all know that, so I'm not going to spend too much time on it. But Ben and Natasha, remember, are discovering those things. Natasha again. What exactly is a notebook? Oh, come on. Is it a Ryan Gosling movie? No, not at all. Notebook is a web-based UI to run code, to run code and documentation at the same time. It's like a Google Doc, but you have the ability to run cells. It is also, you are able to save it. You can share the actual output with others, so it's a great tool for doing data science and also collaboration between data scientists. Now, there is multiple flavor of notebooks out there. The one I'm going to talk about today is Jupyter. Jupyter is, I believe, the most used, most widely adopted notebook out there. There's others. Zeppelin is one of them, and Databricks Community Edition is one of them. But the one I'm going to talk here is Jupyter specifically. So, how do we do big data analysis with notebooks? Typically, this is the architecture. You have your notebooks connecting to a kernel with Spark support, and then you can bring all your libraries back and forth and basically remotely execute algorithm against the cluster. Big data come back, and you get the output, which is usually a chart or something else. So Ben weigh in, and he starts saying, well, notebooks looks powerful to me, but they seem complicated for a developer like me. For instance, he says, if I want to display a basic chart to do basic data exploration, I need to code against library like Matplotlib or Bokeh or Seaborn. I don't want that. I mean, I really want to focus on my job, and how can you help me? This is where PixieDust comes in. So Zeppelin has an equivalent, and Databricks Community Edition has an equivalent where you can do display and on any data, and he will try his best to render something. That's what PixieDust does. It can visualize data. It also provides something called Pixie Apps, which allow you to embed UI, like dashboard, within your notebook. I'm going to show that in a minute. Allow you to download data directly into your laptop or somewhere on the cloud. You can use Scala directly into a notebook, into a Python notebook, so it has complete interactivity between Scala and Python with variable binding. You can define a variable in Python and use it in Scala the same way, and so on and so forth. And is extensible. Extensibility is key here because as a developer, you can build your own visualization and then inject it into a menu into PixieDust. I'm going to show that. So let's do a quick demo. Classes. So what I'm showing here is data science experience, which is IBM SaaS offering for doing data science. It contains Jupyter Notebooks, Spark services, RStudio, SPSS, machine learning, and so on and so forth. And then here is a project that I prepared that contains a bunch of notebooks, which I open here. So the first thing we do when you try to do data science is you load your data. So first I import PixieDust, it's a library. And then here, PixieDust has also a little nifty helper function that allow you to provide a URL to a CSV to whatever data, and it will do the magic underneath so that you don't have to know too much about how to load data into Spark DataFrame. So it will here create automatically, download the file, and create a data frame for you. And here we are dealing with the San Francisco accident from Open Data. You see here it has also a progress monitoring to be able to monitor all the what's happening into the Spark cluster. And then I can do my initial exploration. And as I said, as I promised, a simple API display, you can run it on any data, so it can be Spark DataFrame, RDD, Pandas, JSON, and we keep adding more and more. It will introspect the data, and you'll be able to generate those charts. It generates a little menu here with different type of charts, and you can add to it very easily. It's all the APIs out there that you can use, and each of those have options. So here, for instance, I have a bar chart. I can use my options to change the keys and the values. I can decide to go with a subplot. So here, oh, looks like my machine. All right, complete freeze. That's to show you that it's live data. Anyway, moving on. So this particular library allow you to also support multiple renderer. Here on the right, you can have Bokeh, you can have Matplotlib. We have also with Mapbox, Google Charts, and you can keep adding them as you wish. So that's great. That's not great. My machine is completely frozen. That's not good. What is going on? Sorry about that. I'm just going to try to see if I can. I have what people can say a complete anxiety attack right now. It's probably the magic of PixieDust, but I don't understand why I don't get any feedback. Probably need to, is it the driver who's just, yeah, I don't know, it's all frozen. Crashing completely. Can I quit it? Yeah, quit it. I get nothing. Hard reset. Okay. Can we move? Do you have my Can you reset it in the meantime? Do you have my slide here? I don't think you do. but it's a PDF. It's not. All right, when you're rebooting this, maybe you can you reboot it for me? All right, sorry about that. I'm going to try to keep moving on. Okay. Yes. Okay. I'm going to keep moving just for the. I'm sure I just showed you the actual visualizations. Let's keep moving. Ben is come back and say, this is great, this is Python, but I'm more comfortable with Scala. Can you help me? Well, PixieDust also work with Scala Notebooks. So what we did was we built a bridge that allow you to, from a Scala notebook with a Scala kernel, allow you to run the exact same API display, running the exact same Python rendering engine in the back end. And you can do it directly from Scala, which is pretty nice if you are dealing with library that you like and you don't want Python, you can do that directly there. Okay, let me see. Maybe my machine is back. Sorry about that. Okay, so we're back on track. My machine is up. Okay, so I'm going to switch again. Thank you. Hopefully this time it's going to work. I may have some more quirk, but we're getting into the I'm back on. Okay, slideshow. Okay, so we've looked at PixieDust as a way to visualize, auto-visualize your data, to bring Scala into your Python notebook. It has all kinds of other utility functions, but Natasha is still not convinced. Everything is expressed in code in Notebook, which is great for data scientists, but not for line of business users. And like I said before, you can create great algorithm, but at the end you end up with a large notebook with a lot of cells to run, and that's not very nice. So here, there's another feature of PixieDust called Pixie Apps, which basically allow you to compose those widgets that we saw before into a logical application, a mini application within your notebook. It's entirely running into your notebook. So it's not something that I would advise to run into production, but if you're dealing with the data scientist, working with the developer, trying to build a dashboard, for instance, you're trying to bring them together and cutting the actual barrier that you have by having them collaborating directly on the notebook. The data scientist can run the algorithm, the one that she's good at, and the developer can working with the actual developer, build a dashboard which can allow for rapid iteration. So use cases that you have with Pixie Apps, you can do dashboards, data browser. So imagine, for instance, within the notebook that you have a Pixie app that will allow you to browse your own backend, like Postgres or something that of your own making, and allow you to directly browse the views and bring the data with a simple click without having you to learn SQL context, .read and .write, and all the options that we know could be very hard to master. So let's look at some examples. Here's a dashboard that we've built with a nonprofit organization called Pstack. They monitor unrest data across the Middle East. So they have data like food prices, satellite images, Twitter feeds, and what they built is using Watson machine learnings. They built indicators, scoring, where they can give you some sort of a weather on the geopolitical situation in some area. So CIO can log into that particular dashboard, and if they have operation in this area, they can know if there is a problem or if some protests are going to disrupt their business. So here we built a dashboard that uses Mapbox, and all of this is only a simple line of code with HTML, and I'm going to show that in a minute. This is another example, the same dashboard with a Grand Truth Explorer. And as you can see, it also has an eventing system where you can have events flowing from widget to be able to be more responsive. Another use case, like I said, data browser directly from the notebook. All you have to do here, for instance, we're dealing with Cloudant, which is based on CouchDB. It's a NoSQL DB. And to be able to load data from there, you needed to know the intricacy of the syntax. Here, we're providing them with the browser directly. They can call the actual Pixie app. They will get, on the right here, they will get the list of databases. They can select a database, go and look at the views. They can do queries. And once they're happy, they just have to click on the Generate Data Frame to get a Spark data frame and start working with it. OK, so, but Ben is not convinced now. He says, oh, I have to learn another framework. Can you tell me more? So let's look at a sample Pixie app Hello World. In this particular sample, what I want to do is create 2 views, and I want to be able to switch between them. So a Pixie app is nothing more than a class, a Python class that you tag with a Pixie app annotation. And then you create what we call routes to views. So you have the default routes, and a method that is tagged with the routes. All they have to do as the contract is return HTML fragment right here. In this HTML fragment, you have custom attributes that are fully documented that allow you to set state on this. And the PixieDust runtime will automatically detect clicks event and will be able to connect with the kernel, making a kernel request, and be able to go back and forth. So here I have a second view, clicked equal true. And then you see here, when you click on the first button, it will trigger the second view. And then the second view has itself a fragment that goes back to the first view. Very simple Hello World, just to show you how you will build that. And then to run it, you just instantiate the class and call the run method. So let's see a little bit more complicated. How do you deal with data? I talked about PixieDust visualization before. Here, what I want to do is I want to be able to create a little dashboard with buttons. And then when I click on a button, I want to be able to show, let's say, a bar chart or something like that. So first, I create a placeholder div. See, it's all declarative. I just declare my HTML, my div. In the input button now, I have a PD target that says the results going into that div. I bind this particular request to the entity, and then I give options, which those options are the PixieDust display options. And then finally, when I run it, I pass my entity that will be there. So that's all it takes to build a very impressive dashboard where you can leverage all the PixieDust visualization, Mapbox, and so on. If you want to see more documentation about that, you can go to this URL where we have started to document all the Pixie app custom attributes. OK, so now they are sold. They're going to agree on the architecture. Remember, they have to build this app, and it's all going to be in a notebook. So Ben is Scala expert, is going to build the processing of the tweets directly from Twitter, and then send them to Watson Tone Analyzer, which is one of our cognitive services on Bluemix. And then he's going to enrich each tweet with tones and emotions. And then it's all going to be done into a jar, a Scala jar. He's going to pass that to Natasha, which she's going to use PixieDust Scala Bridge to be able to load this particular library, and then it's going to start doing some data analysis. So that's what they agree on. And then they're going to work together to build the Pixie app. So Ben is on his own doing the data engineering. Natasha is on his own doing some data science. And then they work together building a Pixie app that is going to happen in a notebook. One quick word about Watson Tone Analyzer, which is a service on Bluemix. You can send an input. It will come back with a very detailed scoring on all 13 emotions that we have, like anger and disgust and fear and so on. All right, so let's look at the demo. hopefully. This is the part where, okay, so you see here we have our notebook. I can import the jar directly from there. I pass my credentials. I use the Scala bridge, which is a Scala magic, to be able to start the Spark streaming to Twitter. Notice something, we've defined Python variable here. We can use them directly into a Scala language, double binding. The streamer goes, and then I'm able to create my data frame, which is now enriched. I have the author here, and I have all my emotions right there. So let's try to run this thing. This is what I can do with display. I can show a bunch of bar charts and then do some data science. That's the Natasha part. But then at the end, she wants to run the actual app. So I'm going to run this piece. Hopefully that's going to work. I may have to restart because I just started. Yeah, let me do this quickly. We have some time. Yeah, he asked me to reload. Boom. Kernel ready. Let's quickly do this. Okay. Now I go back to look at my app. And again, the Pixie app is usually one line of code. You encapsulate everything into a class, and to run it, it's usually one line, no more. So when I run it, it will show me a dialog. I'm going to make it a little bit bigger so you can see. Okay, let's do it. View, full screen. So here I have my dashboard. I can pass some query, like let's do Trump and Russia, because I know I'm going to get a lot of stuff. I can click on the start streaming, and you see everything is encapsulated. All the algorithm that we've built before, the long link, is encapsulated into one UI. And if it works, you will see the streaming logs going in. You see here on the right, I'm starting to get some logging information, and then it's directly transmitted into the UI. And on the left, you're going to start seeing the tweets that are related to Trump. Those are live tweets, by the way. So you can see here each tweet that I'm getting. I can hover over them and then get some emotions right there. And then when we have enough data, you will start seeing charts, live charts, starting to show up in the UI. There you go. And I can leave it like that, right? And keep going. It's real data live. So if I let it go, you'll see a lot of information. But what I've done here is build a dashboard that runs directly into a notebook, and you have complete integration, because if I stop this, all the data that has been captured, I can recuperate it into a data frame. So if I stop it and say back to notebook, you will see that a new variable called tweets has been created for me, and I can go and use PixieDust display on the tweets to show the actual things. So what I just showed is a complete integration between the developer and the data science working together nicely. So just oops, sorry about that. Another quick demo, the Pstack that I promised you. I'm just going to make sure that the kernel is there. So this is the Pstack application. You see one line of code, Pixie Apps board, which is the code is on GitHub. You can see it. I can run it. I can get the actual dashboard running, and again, completely inside a notebook. And I can have a Google chart here, which is also a PixieDust visualization. Just a few things. I can select, go and fetch data against the data source from Pstack, and then when it comes back, I'm going to see the actual dashboard with all the indicators and so on. So all this code is on GitHub. You can go and look at it if you want to start experimenting with it, and you can see here the actual thing going. This is the actual map box. And like I said, there's an eventing system between them that allow me to pass event between widgets so they can be responsive. And people have a hard time believing that this is running into a notebook from a Python backend class, which is really, really only mostly HTML and some Python mingled into it. Okay? So let's go back to our presentation. So I can. All right. Now they go to the VP, and the VP, of course, is happy. They can keep their job. No promotion still. All right. So I showed you quickly in 30 minutes what PixieDust could be. What's next for PixieDust? Well, we want to start visualization of streaming data. We're going to start with structured streaming, Kafka, and maybe IBM Stream so that you can very easily, again, graphically, connect to a stream and then see the live data, a line chart or time series and so on. We want to be able to look. So one question we get all the time, this is great, but works only in a notebook. What if I want to embed it into my app? We are working right now on a way to publish this Pixie app that runs on a notebook directly into your web app by using some embedded code that you can put into an HTML, and you'll be able to, through some remote gateway calls, you still need a Python kernel in the back end because everything is running on Python, but you'll be able to bridge all this with simple embedding code into your HTML. Some visualization enhancement, the ability to run Node.js, that's a big thing as well. A lot of our developers know Node, and being able to load data directly into your notebook from Node library, it's extremely valuable for them. So we already have a prototype working, and we are working on that at the moment. And we want to support Jupyter Labs and Jupyter Hub in the future. And as always, you can go on the repo. We already have quite a few external contributions. We love PRs, and they will be all evaluated and reviewed in time. This is my conclusion. My conclusion is that data science is a team sport. It's not only the purview of data scientists, and bringing the tool of data science to the developer is extremely important. Those are the resources. If you take pictures, that you can go. There's some blog posts, how we build the application and what's new. And if you want to learn more, we are running a hackathon with PixieDust as part of the toolbox on the search for extraterrestrial life. The deadline is tonight at 10 p.m. for the in-person, so be quick. But otherwise, there's the online code challenge, which is going to go running June and July. Little interview that I did about why we did PixieDust and how we care about developers and data scientists working together. And finally, this afternoon at 3, we're doing a complete bootcamp to build a Pixie app that relates to accident data in San Francisco and how we can explain those accidents with open data. It's at 3 p.m. at Galvanize. I think we have a few more seats open if you want to sign up. And thank you. Questions?
Thank you, David. Thank you, wonderful. We only got about a minute, and I know you guys are hungry, so if you can quickly ask your question in 1 minute, David will be here, or we can actually corner him around the corner when he's on his way out. Give a big hand to David. Any questions, please?
Yes?
PixieDust, can we run this on our instance of Jupyter, or do we need the IBM?
So at the moment, you can only run it on Jupyter with Python and Scala. R has been asked. It's not a big priority right now, but it's only work to be able to make it run.
Our instance. It needs to be run on IBM hosted.
No. Oh, great questions. It runs on any flavor on Jupyter, and it runs with or without Spark. You can have a plain vanilla Python notebook. It will downgrade gracefully, not show you all the Spark features. It works equally well on that, yes. Great question.
We only had time for one question, unfortunately, but he'll be here around after this over, so just quickly ask one question.
You said that variables are bound in two ways.
Yeah.
I mean, Python and Scala. Is it also applicable to code, like functions and stuff?
I didn't hear the last piece.
Is it also applicable to methods or functions?
Yes,
The two-way binding?
yes.
So something defined, I define a method in Python and I can use it in Scala code?
So let me explain. The variables, yes, completely. For the functions, you can call Scala function directly from your Python. Of course, that's the goal of the bridge. The other way around, not at the moment, but I don't think that's a big problem. I don't think that's a use case that people want that much.
Okay.
The most important thing is to pass variables back and forth.
Okay, that's all we have. Thanks a lot, guys. And don't
Thank you.
forget, there's Birds of Feather session. We got 3 more sessions going on during lunchtime. Look for the tables, ruffle some feathers, join for the conversation. We are here for learning, so that's great. Thank you.